Okay, good afternoon, folks, or good morning or good evening, depending on where you are. My name is Christina, and we're pleased to welcome you to the Washington Labs Academy webinar series. We hope you find the next hour or so useful and informative. We've developed our webinar series to deal with some of the technical and administrative issues that our customers face on a day-to-day basis. We recognize that engineering challenges can be complex, and we're always looking for ways to support the technology industry. Before we begin, I want to go over a couple of housekeeping details. First, I hope everyone is able to see the title slide on their computer. We have muted everyone's microphone to keep the meeting quality as high as possible. A recording of the presentation is underway, and a link will be sent to all attendees. We will go through all questions at the end of the presentation as time permits. A full screen view may be preferred, so the selection at your computer can be done by using the menu panel. In the menu on your screen, go to View and then select Full Screen. We estimate the main bulk of the presentation will take about 1 hour, and we will allow some time for questions at the end. We encourage questions during the presentation. You can submit a question by enabling the chat icon at the top or side of your screen and typing your question to the host. We'd like to hear from you. You can contact us via phone or email, or you may contact the presenter directly. Send your email to mikeb@wll.com. And now I'd like to introduce our speaker, Michael Violette, co-founder and chief executive officer of Washington Laboratories Limited. Mike has 25 years of experience in FCC, CE, IC testing, and certification. Mike is a professional engineer and an INARDI certified EMC engineer. He's currently on the board of directors of ACIL and RAB QSA. He has presented numerous live and webinar events on technical, measurement, and regulatory requirements for electronic devices. Mike is a notified body for the Radio and Telecommunications Terminal Equipment Directive and EMC Directive. In addition to his own insight, he likes to bring guest presenters into webinar series to add subject matter, insight, and expertise. So without further ado, let me go ahead and hand the presentation over to you, Mike.
Thank you for the introduction, Christina. Pleased to have everyone here this morning or this afternoon or this evening. Welcome to our FCC Part 15 Essentials series. Today's discussion will focus on some of the 15 C, D, E, and F requirements for radio frequency devices, which are a critical part of our technology infrastructure in a global sense. Briefly about Washington Laboratories, we've been in business since 1989 and focus on EMC, product safety, RF, and environmental activities. We serve the commercial, consumer, defense, and aerospace markets in the Mid-Atlantic area and overseas. We also have activities focused in Europe and in China. We've worked about 15,000 different projects since our inception, everything from vehicles to ground-based satellite systems. We do a lot of work in the nuclear power industry for electromagnetic compatibility. Today's discussion, I'll have a little bit of background and overview on the critical part, the role that the FCC Part 15 devices play in our technology infrastructure. We'll discuss some of the regulatory requirements for the U.S. and a little bit about Canada. And we'll close out with a few comments about the requirements in Asia, particularly in China, Japan, and Australia, which are also decent, good markets for our technology innovators from the United States and overseas. There's been a tremendous expansion of wireless devices in the last 20 years. A lot of this has to do with international standards being harmonized and global markets being readily more accessed. The IEEE has driven a lot of these innovations through their 802.11 and related industry standards. Of course, the Europeans have a very vibrant standards association and activities that are also driving these technologies. We'll talk a little bit about these trends and also how the low-power unlicensed devices are really shaping a lot of our RF ecosystems. As time more and more bands of operation are opening, and this is critical in order to evolve into our next generation of wireless communications, and we'll have a few discussion points about that. One of the things that we've noticed in our own business have been inquiries from folks that have joined the Kickstarter campaign activity, and a lot of these Kickstarter devices employ wireless devices. So we would take a quick look at that because I think it's an interesting trend. A trending topic is Internet of Things, and this is hotly discussed among many forums globally, and this Internet of Things phenomena is about machines being connected everywhere all the time. Briefly on Kickstarter, I did a little research on the activity over the last couple of years. Just in 2013 alone, last time I checked, about $380 million had been pledged into various Kickstarter campaigns, and about $1 billion inception of this notion. There are more than upwards of 8 million backers in 200 countries and territories across the gamut, from people coming up with novelties such as postcards to rock and roll musicians looking to kickstart their careers in the studio. There have been some novel projects. $34,000 was pledged for a human-powered flight, and it looks like it was successful according to this. So there's been dreamers there. There's been innovators as well. One particular project raised almost $9 million, 10 times more than the goal. And currently there are upwards of 900 technology projects which are active on the Kickstarter website. And as I mentioned before, a lot of these things utilize the Wi-Fi and unlicensed device bands that are covered by the Part 15 regulations. There are also some, I would say, novel, innovative people that have raised a lot of money for some maybe some interesting entertainment type of projects. Exploding Kittens game raised almost $9 million for their innovative concept. Back to technology, one of the trending areas of growth is the Internet of Things. This implies a lot of machine-to-machine communications. And examining some of the data traffic volumes, you'll see that machine-to-machine connections are outpacing person-to-person connections widely. The essentials of the Internet of Things include sensing, which is important for the integration of machine and sensing applications that report back data, telemetry type data, back to the intranets, which can be further processed. The transport mechanism is the methods of how to move the data amongst the various nodes on the Internet of Things. There's a huge requirements for storage, and a lot of these storage and application processing activities are now more and more being done in the cloud. And in the full rollout of the IoT, you'll see more analysis of these data. You've probably heard the term big data. And if you look at the volume of the amount of data that's being collected by these various sensing applications, you'll see that a lot of this stuff gets processed in the cloud, analyzed, sorted, and using adaptive algorithms can adjust the way the machines that are connected to themselves can perform and report back their activities to the algorithm programs. This implies that there's also a method of control. So, for example, one might be an adaptive technology that learns your behavior as you go about your daily life, and your home will learn how to adapt to your patterns of lifestyle. For example, it might know that you typically come home at 6 p.m. in the evening, so it might adjust the temperature or the lighting of your house that has been learned over time as you input various sense inputs from your devices connected to the internet. So this goes from everything from water control, energy control, and also home heating and cooling. One of the interesting trends is the volume of money that's being spent over the internet through the machine-to-machine connections. This chart shows the growth of connections and revenue from Verizon that uses its cellular backbone to connect machines to each other. So there's something like nearly 30% year-on-year growth in the volume of internet connections being routed through Verizon's network, resulting in about $6 in recent revenue numbers, and they're expecting that their connections will be $5.5 billion just in the Verizon network alone. So there's a tremendous amount of connectivity, a tremendous amount of revenue potentials, and this all points back to wireless connections that are regulated under FCC Part 15. So ultimately, the full rollout of the IoT will be improvements in the industrial and consumer sectors. You can imagine that efficiencies in fleet management, shipping, logistics, the implementation of the smart grid for higher efficiency for usage and smarter application of electric power, the improvements in traffic prediction and safety, home security, healthcare, patient monitoring, point of sales, and something called geofencing. And an application of this might be in senior living situations or healthcare environments where you need to keep track of patients and customers. So growth sectors are going to be drivers in this particular area, and this will be growth in the sensing applications, radio frequency identification, video everywhere. You'll have ubiquitous amounts of volumes of video streaming into the internet. This is already being rolled out quite quickly. You'll also see expansions in network transport, which means that you're going to have interconnectivity between Wi-Fi devices, which are regulated under Part 15, and cellular data networks. The next gen communications, which is typically referred to as 5G at this point, is quickly being defined. And part of this is going to require and allow astonishingly high data rates in the gigabits per second. These things will ultimately have a increased profusion of short-range devices, which can be either connected to products or machinery, or can be worn, such as the wearables that are now increasingly more popular. On the consumer side, the IoT will include home security and monitoring, things like automated and remote controllable thermostats, entertainment, and connected cars. One application of this is real-time monitoring of habits, which be fed back into insurance carriers that can, in a real-time sense, change the premiums according to how well or how not so well you might drive your car. And one of the interesting things about this is privacy concerns. So a lot of discussion being done on high levels about how the protection of consumer and individual habits will be shielded in some way from this vast data collection. On the industrial side, you can see that we can embed sensors in roads and other infrastructure to report back conditions of air or near failure points, so that preventative maintenance might be implemented on roads and bridges. Business-to-business connections are growing more and more. Healthcare is a critical part of the IoT, and of course the power grid, the integration of solar and renewable in microgrids into the power grid is a critical part of the Internet of Things. And a lot of this points back to the ubiquity of FCC Part 15 devices. More and more, the price points of some of these modules, which will be in a lot of cases pre-approved, is being driven down. And in order for the Internet of Things to be fully realized, you're going to have extremely cheap, energy-efficient modules that can be fitted onto the various devices and products. So this will continue to press innovation and also continue to press the rollout of wireless devices, all of which comes with a little bit of a cost in the sense is that our spectrum will become more crowded. So it's critical that compliance with the Part 15 be essential in the development of any of these devices. critically linked to this is the rollout of the Wi-Fi, which has various, according to the Wi-Fi Alliance, approximately 12 billion devices have been deployed since 2002, which is an amazing amount of devices. But it's only going to grow. 3 billion units are expected to ship in 2016, and this is expected to double again in 2020, resulting in what's sometimes referred to as Wi-Fi ubiquity. This screenshot to the right of this shows a typical coffee shop that I found in Beijing when I was searching for a wireless network to connect to. And so all these devices are obviously contending for the same spectrum in the same area. And in order for these things to be effectively operating, control of their emissions is essential. And the FCC Part 15 requirements are all about. I had a unique experience just the other day. Now it's available on airplanes more and more. And so I had a connection somewhere over the Pacific and decided to try to WeChat one of my colleagues. So we had about a 10-minute conversation. I was able to contact her and discuss some business items. So I thought it was pretty astonishing that I could fly at 33,000 feet at 1,000 kilometers per hour and have a vocal connection between the plane and ground. There were a little bit of issues with the connectivity. It was not certainly as clear as some phone calls in the traditional sense, which pushes what's called the quality of experience metric. That is one measure of the success of the connectivity. But back to our regulatory requirements, on a high level, we have to concern ourselves with what's called electromagnetic compatibility. And this is in the broadest sense, things operating together without causing interference amongst the different systems. And this is largely driven by spectrum control. And these things will govern the behavior of wireless transmitters, which is a lot of our discussion today. Unrelated subject matter in the compliance arena is product safety. We also need to consider protection of consumers and users and even domestic animals from electrical, mechanical, fire, and chemical hazards. The environment is a critical thing that we need to safeguard, so there are also requirements for materials toxicity limitations for various types of things that we put into our electronic devices. And there are limits on the amount of hazardous substances that may be used in electronic devices, notably lead, which has been largely removed from printed circuit board soldered connections. Other regulations look at the disposal of waste from electronic products. The Europeans are very active in this area, and something called the REACH Directive, which is a listing database of chemical hazards. There are other compliance requirements, including requirements for toy safety, explosive atmospheres that are devices that might be used, say, in a petroleum environment or something that has potentially explosive atmospheres. And there are various regulations for other types of environments, such as for pressure vessels and for automotives. Some of the safety issues that we need to concern ourselves with are mechanical safety. I want to hurt body and limb if a device has any sharp edges or things that you might catch your limbs in. Electrical safety is critical, and IEC 950 is the dominant standard for information technology equipment. Coupled with safety is the protection of humans from excessive radiation hazard exposure, and this is largely detailed in the specific absorption rate and MPE requirements that are covered by the FCC and across the international standards for radio devices. Laser safety is in the United States is largely regulated by the Food and Drug Administration under their Center for Devices and Radiological Health. And things that might be employed here are CD-ROM type players that embed lasers in their operation. For consumer products, the compliance definitions include Declaration of Conformity, or DOC, or Supplier's Declaration of Conformity. Currently in the FCC regimen for unintentional emitters under Part 15, a manufacturer is allowed to have a declaration of conformity that they issue based on test results that are performed in an accredited test laboratory. So this is, in a sense, kind of a self-certification. And this is reserved for devices that are largely benign from a radio frequency point of view, or well-behaved, or have historically a good measure of compliance to the requirements. Another level is so-called third-party certification. In this case, a manufacturer would go to a test laboratory which would produce accredited test results, and they might be submitted to a third party that has the accreditation to certify the device. This is largely served by the independent laboratory community, and trust is developed under accreditation system, which is again another independent party that would accredit the labs and certification bodies. Ultimately, your device may end up with a very busy label. This is a kind of a typical power supply that shows the various logos for the various types of approvals that include electrical safety, EMC, and has specific warnings and hazards that have been required by the various standards. So this is an international power supply that uses these various certifications in order to gain market access. Well, back to the FCC. In North America, the regulatory bodies include the Federal Communication Commission and the Innovation, Science, and Economic Development Department of Canada, ISED, which is formerly known as Industry Canada. And these regulatory bodies in the U.S. and Canada govern intentional and unintentional emitters, devices that intentionally radiate energy or unintentionally radiate energy, and include categories for licensed and unlicensed devices, and we'll discuss that a little bit more. On the safety side, in the U.S., regulatory authorities include the Occupational Safety and Health Administration, or OSHA, is mandated to protect workers in the workplace, and the National Electrical Code, which is required for devices that will be connected to the electric grid. Medical devices are regulated by the Food and Drug Administration, which has their own set of EMC criteria, including radiated, conducted, immunity, and emissions. And in order to successfully market a device in the United States, you must get what's called a pre-market notification from the FDA, which means that you have to submit a technical package that describes your device, as well as all the test results that have been applied to the product. As I mentioned before, laser is regulated by FDA. Briefly, across the pond, in Europe, the CE marking is the dominant regulatory proof of conformity, and there are a number of directives that must be adhered to depending on your device. And when you have compliance with these directives, the manufacturer can place the CE marking on there. This is largely a self-declaration regimen, so the manufacturer can do the testing and then apply the CE marking if they comply with the harmonized standards. Now, there are maybe some device classes which are inherently dangerous, and you may need to get what's called a notified body opinion for that kind of product, an example being a chainsaw. This is a list of a number of directives that may apply to your device. The list here includes directives that include some manner of electromagnetic compatibility, and these are starred here with an asterisk. Now, obviously, the EMC directive by definition includes electromagnetic compatibility. The machinery directive applies for products that move, any kind of machine, and that includes EMC. Active implantable medical devices include EMC. The radio and telecommunications terminal equipment directive includes EMC. There's a new radio equipment directive that will be enforced in July of 2016. And Europe has a number of environmental requirements for devices that are placed on the market. Again, this is a self-declaration, but in some cases, there's a registration process for the devices that get placed on the market. Other markets, well, it's country by country specific. It depends on the economic development of that market pretty much, whether they have a defined regimen or not. Most countries do regulate their radio spectrum. Many countries regulate their product safety in various degrees. And some markets, particularly, as I mentioned, the EU, regulate materials in products to protect against products that may pollute landfills. One of the compliance strategies that we try to recommend is to first identify your target markets. Refer to international standards. Largely, you'll be fairly successful if you use international standards because that's been the driving force in the last 20 years. And if you're integrating a device in some way, make sure that you source components that are already approved, because you can get bit when you get to the test laboratory, to the compliance phase. So some upfront research is definitely recommended on devices that you're integrated together. So that's an overview basically of some global strategies and requirements. There's much more detail, of course, but hopefully that's a general introduction to why we need to look at the regulations. In the United States, the FCC has what's called the Code of Federal Regulations, Title 47. So this title is one of 100 titles of federal regs that include everything from food safety to nuclear power. Title 47 is for telecommunications. And under Title 47, there's a number of rule parts. Part 2 of CFR 47 included general requirements for devices that apply to all radio frequency type of equipment. Of core interest in our presentation here is Part 15, which looks at unlicensed devices. And these include anything from laptop computers to low-power remote control devices, Bluetooth devices, Wi-Fi, many devices that we use in the home and in industry. There are several rule parts for licensed devices. Some example of these are Part 22 and Part 24, which apply to cellular or mobile devices. Other interesting parts that might be of interest include Part 87 and Part 90, which are licensed devices for marine applications or for land mobile, such as taxi or public radio type of systems. Under Part 2 is a couple of very critical paragraphs with regard to human health and safety from radio frequency hazards. This is largely either referred to as SAR or MPE, and it's based on an ANSI C95.1, which looks at the health effects from non-ionizing radiation. So this is non-X-ray type of radiation that typically get associated with radio products that transmit radio frequency communications. The FCC was authorized in 1934 by Congress to make available a rapid, efficient, nationwide and worldwide wire and radio communication service for the purpose of the national defense. And I thought that was quite curious that particular phrase was in there. But if you consider the context of the time, the mid-30s, there was a lot of turmoil in Europe. It was the middle of the Depression. So some concern about homeland security, even back then, was critical to FCC's role. And it's interesting that we've largely implemented this worldwide radio communication service, which is our very marvelous blend of radio and other communication modes that connect us around the world. So the FCC is responsible for the integrity of the airwaves, the use of spectrum, the licensing and operation of RF systems, and has a very robust certification program, which has largely been, it's just completely been turned over to the private sector at this point. The FCC system includes a database of thousands of products which have information on the frequency, power of the device, the limitation on use, and responsible parties. So the FCC database is a rich trove of information that can help you develop and determine whether your device can legally be operated, how it can be operated. It also could give you some competitive insight into what other manufacturers have done successfully in rolling out their devices. It also has a lot of information on the radio frequency safety of these individual devices. There are different classes of equipment authorizations under the FCC. The first or most lenient level is so-called verification, and this is reserved for what's called the least interfering equipment. These include devices such as Class A digital devices. A Class A digital device is a device that has been designed to be used in an industrial or business situation where there's a less likelihood of interference to broadcast reception, which is a fundamental part of FCC Part 15. Radio receivers, which are largely benign, are also fall under the verification. For other products that may have more wider distribution in the residential area, a declaration of conformity or DOC process is required. So this applies to Class B digital devices, computer and peripherals, laptops, computers, home computing types of systems, fax machines, if we still use those, that kind of devices. These all must comply with the Class B limits, which are more strict than the Class A limits. And the requirement there is because they may be very widespread devices, there's a larger potential for interference to radio broadcast receiver interference. The highest level or most strict requirements are reserved for products that must meet certification. And certification is reserved at this point to intentional transmitters, both unlicensed and licensed devices. It includes Wi-Fi routers, laptops with most every laptop has a Wi-Fi transmitter, Bluetooth devices, anything that may use the radio frequency spectrum, either an unlicensed case or licensed case. As I mentioned before, ICED, or formerly Industry Canada, has authority on spectrum and has very similar technical limits and rules, has a verification for digital devices similar to the FCC, that has a standalone certification program for products that enter Canada. So if you have a transmitter device and you get FCC, you may get Industry Canada also using the same set of test data, but you have to apply for a separate type of certification. When the FCC privatized the certification program in 2000, about 4,000 devices were certified under their system. In the last year or so, more than 19,000 devices had been certified in 2015, which is an amazing amount of growth. And about 50% of these devices were either designed, developed, and or tested in China, which is experienced about a 25 times growth rate in the last 10 years in terms of the certifications. And I'll come back to that in a moment because there's some critical timing around that particular topic. These devices include things that radiate a few milliwatts to many hundreds of watts for things like transmitter base stations for cell systems. As I mentioned before, the unlicensed low-power devices are proliferating, and these unlicensed devices are largely regulated by FCC Part 15. Broadband technologies are expanding. Complex modulations that pack bits, more and more bits per hertz, are more and more being used in order to increase the requirements for broadband communications. And frequency allocations are expanding. Things are being refarmed. There's been changes to government allocations that have been moved over to industry. There's been enormous amounts of money made in spectrum auctions as mobile carriers want to gather more frequencies for use for their devices. This is a grant of equipment authorization example of something that was issued under the aegis of the FCC, and you can see that it includes information on the grantee. It also includes technical information on the frequency and power of the device, and also something called grant notes, with specific limitations or conditions of use that must be applied to the device by the operator. The grant can be downloaded, this kind of grant can be downloaded from the FCC website as long as you have something called the certification or FCC ID number. And the ID number is constructed in accordance to the following format. The FCC ID includes the grantee code, which is the AAAA, the 5 alpha character code. And this is issued by the FCC and identifies the responsible party or the grantee. The rest of the number is up to the discretion of the manufacturer. And if you have that FCC ID number, you can go to the FCC Database, input that, and get information about the applicant, the test reports, and any non-confidential data that the applicant may have filed. Under the FCC CFR regulations, these are available at the website shown here, and they're kept up to date with new releases of the rules, so it's advisable to go and check back frequently as you go through the process of developing your product or going through the compliance process. Part 15 includes subparts C, D, and E for unlicensed low-power transmitters, and there are a number of other parts that are all applied to licensed devices of various types. Examples of unlicensed devices include Wi-Fi devices, Bluetooth, cordless phones, many remote control devices. There are some licensed remote control devices, but most remotes are unlicensed. Ultra-wideband equipment, spread spectrum devices, unlicensed national information infrastructure or uniband devices are under the regulations of FCC 15. Because these things are unlicensed, which means that anybody can use them anytime, this particular spectrum in use is unprotected by the Commission. In that case, it means that if there's interference to your device, you don't have any recourse to go to the FCC to cease operation. Largely, that's true. Licensed devices, on the other hand, include things like land mobile radio, cellular, telephones. Your mobile device actually is a licensed device, and the license holder is typically the carrier. Broadcast transmitters are licensed. Business radio applications such as taxi or land mobile devices, radars are licensed. And in this case, the license use is protected, which means that if interference is experienced with devices, the interferer must cease operations or find a remedy to that. One aspect of the FCC system, which is important for interpretation of rules and guidance on testing and certification, is the so-called knowledge database or KDB systems. And most topics have a KDB that's written on them, and you can find this at that website here under the FCC system. And you can search various terms for questions that have been answered before or interpretations on test methods, the application of rules and regulations, guidance on marketing, etc. It's also a route to find out to the FCC about any non-standard test methods. And it's used quite regularly in the certification industry when there are new technologies where there may be unclear direction in the rules. You can get an interpretation from the FCC. And this can be either in a public way or it can be confidential in a private communication between the requestor and the FCC. A little about the technical requirements for these devices. As I mentioned before, licensed devices are more regulated and are protected. Part 2 covers the general requirements, and under the rules there are about 15 different radio service parts which require some kind of equipment authorization. And the rules can be found here in the various categories for the products. Measurement standards are dictated by the ANSI standards, ANSI C63.4, which is the committee that looks at the measurement procedures for unlicensed and licensed devices. Current rules that have been adopted by the FCC in recent rulemaking is this ANSI C63.4 2014. Right now we're in the middle of a transition period, and the earlier versions of C63.4 can be used up until July 12, 2016. A relatively new development in the last few years is ANSI C63.10, which is measurement procedures for unlicensed wireless devices, which is a critical part of what we're talking about here. And this becomes mandatory, the 2013 version becomes mandatory after July 12, 2016. And this July 12th is a pretty seminal date for a variety of reasons, which I'll touch on in a moment. So if we take a look at what's happening in the FCC Part 15, in the year 2011, last time I checked, there were about 4,000 digital transmission systems, or DTS, devices that were approved, about 2,500 spread spectrum devices, and about 1,800 low power communications. So this is about a third of the total authorization. So I think it's important to look at these unlicensed requirements. So what are the general requirements for Part 15 devices? Well, a good design, which is a little bit of mother here, which means that the emissions must be below the limits. A critical part of Part 15 is that the user is not allowed to change the power frequency of the device. They must also, users of the Part 15 devices must cease operation if they cause interference to licensed users. And operators must accept interference. The label, which may be on the product or in the user manual, basically states these things. It must not cause harmful interference and must accept interference. When you're looking at testing an intentional emitter that operates at some frequency, you have to check the frequency band of operation according to this following table. If your device operates in a frequency range of 1 megahertz or less, it's permissible to test at one frequency, typically of the range. If you have a device that operates over a 10 megahertz frequency range, you must test at a minimum of 2 frequencies, one near the top and one near the bottom of the range. And for devices that operate over 10 megahertz in frequency range, you must test 3 different frequency of operations, one near the top, one near the middle, and one near the bottom of the frequency range. This is to make sure that you characterize the device power output across the operating band, and across any spurious emissions frequencies. For unintentional emitters, the frequency range of scanning frequency range depends on the clock rate. Typically, for devices, the general rule of thumb is that you must scan the frequency range up to 10 times the harmonic of the device. And depending on the operating frequency, if you're operating below 10 gigahertz, you stop at 40 gigahertz as the upper frequency range. If you have a clock rate, a fundamental rate that's either intentionally generated or used from 10 to 30 gigahertz, you would test to the 5th harmonic, or an upper frequency range of 100 gigahertz. If your device is operating above 30 gigahertz, you test up to the 5th harmonic, or 200 gigahertz, unless stated otherwise. So that's for intentional emitters. For unintentional emitters, the frequency range of operation depends on the clock rate. When you're making these measurements, depending on the frequency range of operation, your default detector below a gigahertz is to use the quasi-peak adapter of your measurement system. You can use a peak detector as long as the peak emissions comply with the quasi-peak measurements. The default detector above 1 gigahertz is an average detector, where not stated otherwise. So depending on your frequency range of operations, up to 1 gigahertz quasi-peak detector in your measurement system is default. Above 1 gigahertz, the average detector is default. For some emissions which may have a high peak to average ratio, it's typically required that the peak to average ratio be less than 20 decibels. So this means that you have to measure the total peak emissions level and compare it to the average of that same emission. Pulsed emissions allow an averaging for over 100 milliseconds, unless you measure over 100 milliseconds of the pulse train, typically, for a pulsed operation. In this case, you use the peak signal, and you can correct the peak value using a formula that is equal to 20 times the log of the duty cycle, which is defined as the ratio of the on time to the off time over a period of 100 milliseconds, typically. If the pulse train is less than 100 milliseconds, you must measure an average over the length of the pulse train itself. And the duty cycle must be in worst case, which means that you have to test the most on time to get the highest amount of duty cycle. For devices that comply with Part 15, specific labeling requirements are necessary. For declaration of conformity products, you must use the FCC logo, include the trade name and model number. Some regulations or some discussions are now underway to possibly delete or change this requirement and no longer require the FCC logo. This is under a rulemaking that is currently being decided at the Commission. In any event, the label must be permanent. It cannot be removed. It must be visible. It cannot be on a removable part, such as a battery cover. It can be inside of battery cover, for example, inside a device behind a battery cover, but it must be permanently attached to the device. For devices that have a screen, such as mobile phones, the electronic labeling is now allowed, as long as you can access the label and regulatory information in a minimum of 2 clicks, I believe. When applying for a certification or regulation certification, there's a number of documents that must be filed with the certification authority. It includes cover letters, requests for confidentiality, if desired, test reports, any modifications that might have been performed during testing, the user's manual with instructions and warnings, theory of operation. You must have a number of photographs of the setup as well as the device inside and outside. You must submit the FCC ID label artwork and where it's going to be positioned on the device. And there may be a number of attestation statements, such as conditions of installation and use. For ISED, pretty much similar. You must apply the right radio system specification, all the technical documentation. And in this process, for both the FCC and ISED, the certification body runs the information through the regulatory websites which issue the authorization. For the FCC, it's a cert grant of equipment authorization, which I showed before. For ISED, you have to have the device listed on the radio equipment list before you're allowed to sell it. So it's a little bit of a two-part process for Canada. As I mentioned before, most consumer devices are unlicensed, and Part 15 covers these transmitters. So this is a look at the rule parts under Part 15 and the specification of operation. The Commission takes the radio frequency spectrum and has divided it for historical reasons over various frequency bands. And as the technology changes, they have allocated different bands over the years for specific use, such as for RF identification, which is allocated in the 13 megahertz band, typically 13.56. Remote control devices are under 15231. These are things that have a typically a low duty cycle type of operation, such as a garage door opener. You can operate a low power FM radio device, pretty low limits in the 88 to 108 megahertz band. There's also some RFID spectrum allocated at 433. A very active part of the FCC rules is 15.247, which includes unlicensed spread spectrum devices, which have applications for Bluetooth, Zigbee, 802.11 purposes. Vehicle identifications in the 2.9 gig and various places and their vehicle radar. So just a general overview of the FCC rules under the Part 15C. Part 15E is for uni devices, which is 802.11 and related. And Part F is for ultra-wideband devices. So all the technical requirements, the specific limits and rules and operating requirements are under Part 15. Now, one appealing route for approval for device integrators that don't want to go through all the certification is something called a modular approval. So this is great for devices that or manufacturers that have a special use. Maybe it's a sensing or control use, but they want to just integrate wireless into their product without having to go through a certification. So you can get a pre-approved module and integrate it into your host. But you must, if you're doing a modular approval yourself, you must pay attention to some details. And the module is certified for the operation shown in the application. So there's conditions of use typically for modular approvals and applying a modular device. In any event, the module grantee or certificate is responsible for continuing compliance. It doesn't abrogate the responsibility of the integrator. However, ultimately, the certificate holder of the module must make sure that they continue to manufacture the device that complies with the specific rule part. The integrator, however, has some obligation to label the device with a statement that says contains FCC, whatever the ID number, and that must be visible and permanent on the outside of the device. So there's a couple of different routes for modular approvals. In this case, a full modular approval is something that can be used in any host. It must, however, meet 8 important criteria to have a full modular approval, which includes the RF portion must be shielded. You must have onboard voltage regulators that can condition the power. Data buffers must be on the I/O or the baseband. You must comply with the general requirements for the antennas for Part 15, must be correctly labeled, and must meet RF exposure requirements in typical use. It also must be able to be tested standalone. You can create a fixture in order to mount the device, but it must be standalone. In other cases, it can't be integrated inside another host. And it must comply with the rule parts. If you cannot meet one of these fully modular approval routes, there is something called limited modular approval, which is typically allowed for devices that may be used in multiple similar hosts. So you can test with a typical host, and by extension, you can get the certification for other hosts. This is a very convenient way for some manufacturers to integrate wireless into their systems when they have different platforms and can use a similar radio across those platforms, which means that the installation is typically very controlled, and usually by the host is the one that controls the installation. So the modular approvals requirements, you must meet the antenna requirements of section 15.203 and 204, which means that for any unlicensed device under Part 15, typically you must use a unique antenna connector. You must also have that antenna approved for use. You can have multiple antennas that may be approved, but you must make sure that they're included in the application process. As I mentioned before, the modular transmitter must be labeled with its own FCC ID, and you must always consider RF exposure depending on how you're going to integrate the product into your host. So the biggest problems we see are modular approvals are understanding the 8 requirements, and understanding the original grantee is ultimately responsible for compliance. So that's a word on the general FCC Part 15 for making access to the market. What do you do when you receive your grant? Well, as I mentioned before, the FCC is basically a single stop system. Once the certification has been issued, you can ship the product as long as you take care of other authorizations. For Industry Canada, or ISED rather, you have to wait just a little bit, wait for the IC to list your certificate on their radio equipment list. Just want to make some comments about some other markets briefly. Most manufacturers don't look at just the FCC as or the U.S. as a destination. And typically the regulatory regime in other countries depends on a couple of factors. Number one, the development of the country, whether they have the infrastructure, either the size or development sophistication to have a regulatory authority at all. Some do, some don't. Some smaller markets may just accept the FCC certification or a European approval for use in the country. Some other countries, such as China and Brazil, you must test in the local market. You cannot test outside yet, and some of these things may change over time, but that's a condition in some of these larger markets for China and Brazil. For the United States, we have a number of what's called mutual recognition arrangements with some other economies. A very active one and very successful include the U.S.-European MRA, which allows manufacturers in those markets to test locally for each other's markets, and it's been a great boon to trade. There has been some success in Asia-Pacific Economic Cooperation area under the APEC-TEL MRA, and this has been implemented with various economies, Singapore, Hong Kong, Vietnam to a degree, Taiwan, Korea to a degree. And there's a very successful bilateral U.S.-Japan MRA, which allows U.S. manufacturers to test and certify for Japan in the United States and vice versa. Also, we have a very successful U.S.-Canada MRA, which allows cross-transfer trade and certification, recognition of certifications. In South America, there's something called CTEL, which has been largely stalled over the last couple of years. And the particular market that has really been quite restrictive has been China. Leads me to just a brief discussion about dates. The FCC in the past year or so issued some new rules governing the acceptance of test data, which says that after July 12th of this year, countries that do not have an MRA with the United States may not issue certification through their test laboratories, rather test data through their test laboratories that can be accepted for certification. So that's after July 12th. China, Brazil, Russia, India, laboratories in those markets can no longer test for the United States. After October 12th, test data that had been previously generated can no longer be accepted by certification bodies. And what I believe will happen will cause a tremendous amount of concern when Christmas comes, when we expect to have some of these wonderful wireless devices in the store. So it's going to be an interesting next 6 or 7 months. As I mentioned before, there's a successful MRA between Japan and the United States. So United States manufacturers can now test in their local laboratory and certify through an accredited certification body for Japan. And for Japan, there are 4 main classes of products. There's a license-free category, which is interesting, and I'll discuss that in a moment. There are unlicensed categories similar to the FCC Part 15. There are licensed devices such as mobile phones, again, similar to the United States. And there's a category of special equipment that only the Ministry of Information and Communications, or MIC in Japan, can approve. Under the Japan regulations, there's something called the Japan Radio Law, which broadly states out the procedures and requirements. There are ordinances, which include the technical requirements or specifics. And TELEC has some online published procedures which can be taken as reference points. The core things that we need to review are very similar to the FCC, which is the transmitter information, power, oscillation, modulation behavior, the type of device we must understand to certify. You have to specify the type of antenna and the gain, and information on associated or ancillary equipment, and information on the technical details of the device construction. This is a section from a database that we use that shows the radio frequency limits in the 2.4 gigahertz band, which are by and large harmonized with the United States. There are some bands that are extra bands that are allowed in Japan that are not allowed in the United States, but this is basically the 802.11 frequency range for 2.4 gigs. There is one interesting low power device where you do not have to get a certification at all, and you're allowed to transmit at very low levels, which means very short distances. And as long as your device meets these requirements, which are very strict, you don't have to get a certification. We've had many people inquire in this, about using this particular provision, but we have to date not seen many successful applications because the powers are so low. Basically, it's below the FCC Class B limits for unintentional emissions, so it's very tight. Ultimately, here's what a certificate looks like. A certification body can issue this. It's their own certificate. What gets filed with Japan is simply the manufacturer information, the frequency, and the model name. That's for radio transmitters. For general EMC, for information technology equipment, the emission limits are largely voluntary under the VCCI, or Voluntary Control Council on Interference, and this is largely applied to consumer products. In China, there's two typical marks, one is called the CCC mark, which is the China Compulsory Certification mark. And this includes devices that fit in specific categories of electrical safety and EMC. There's also a separate radio transmitter requirement and the network attachment license, which applies to cellular devices. Now, any device that's going to be approved for China must currently be tested in a state-designated laboratory. As I mentioned before, as of July 13th, the regimen is going to change, and China test laboratories will no longer be able to produce test data for certification. Discussions are now underway between the FCC and U.S. government and the China government in order to implement a mutual recognition arrangement. But the outcome at this point is uncertain. But for testing in China, all the necessary stuff that you expect with any application are there. You need to send samples, instructions, and you can use a local agent if you choose to. Australia and New Zealand have a kind of restructured their regulatory compliance into what's called the RCM, or Regulatory Compliance Mark. And this RCM replaces what used to be called the CTIC category of equipment. And it covers all EMC and radio and system, covers all EMC and safety requirements. The ATIC mark had been previously implemented for the ACMA, or the Australian equivalent of FCC. This will ultimately be replaced by the RCM, which will cover all requirements compliance for equipment in Australia and New Zealand. For this approval, you must issue a DOC, Declaration of Conformity, from the manufacturer. You must have a compliance folder, or in European parlance, a technical construction file. there is a registration requirement, and you must have a approved supplier. So that's we're coming up just a little over an hour here. I've got largely completed my presentation, and I open it up for questions.
Hi, Mike. Looks like I got a couple of questions here. Let's see. Are there any Part 15 declaration of conformity requirements for non-medical body area network technology, like fitness monitoring?
So if you have a fitness monitor that has a Bluetooth function, for example, then you would need to comply with FCC Part 15C. So if you intentionally transmit a radio signal, you must get a certification. So something like a Fitbit has a certification, or the Apple Watch, for example, has a Bluetooth function.
Okay. All right, great. Let's see. Next question is, how can I easily determine which rule part applies to my device?
Well, the first thing you have to look at is the frequency of operation, what you're trying to perform. Then you would go to the FCC website, and if it's an unlicensed low-power device, it would certainly fall under Part 15. If it's a mobile phone type of application or something that connects to the network, you'd have to look at the frequency range of operation that's allowed and look at the rule part, either Part 22 or 24, depending on the use. So largely, it's frequency. There's also frequency allocation tables under Part 2, where you can look down the list of those devices and find out what rule part would apply.
All right. Next question. Can you go over items I need to consider for integration on a device with modular approval?
If you're selecting a modular approval to integrate in your device, the first suggestion is to take a look at the grant for that device and make sure that any conditions on the notes are complied with. Because ultimately, the integrator is responsible for making sure that it complies with those restrictions that may be on the grant. A particular concern to the FCC is RF exposure, because you may add a modular approval to something that has another radio. So there's issues there dealing with specific absorption or MPE or radiation hazard limits, and often some of the module will have limits on or conditions of use that you must maintain a certain separation distance between the antenna of the module approved device and any other radiating or transmitting antenna. So you've got to look at the grant first to make sure you have meet those conditions. Then if you're integrating a module and you're burying it inside your host, you have to remember to put the phrase contains FCC XYZ123 on the outside of the device, so any the market inspector, auditing authorities, or whatever can know that there's a radio transmitter inside the device. Those are the two critical things.
Okay. Got a couple more questions if we have a couple more minutes, right?
Sure.
Okay. What is an expected time frame for the approval review after testing is completed?
A nominal time, it can be a week or so. If the device is fairly straightforward, it can be shorter. Some mobile phone applications that we receive may have multiple bands and many hundreds of pages of test data, so it may stretch a little bit longer. But the most critical gating factor is to have a very complete compliance application and make sure that all the information is there, the user information, the technical description, a block diagram, any variants that are being included, The test report must be easy to read, must be comprehensive. You must make sure that you specify all the operating modes completely and describe those modes. It really depends on the quality of the application, frankly, and the more complete and comprehensive and organized the test data are, the faster the review goes.
All right.
Often there's a round of questions, so there may be some response times depending on the applicant's ability to respond to those questions or fill in any missing or information that has raised a question of the reviewer.
Okay. We've got one more question here. It says, could a single transmitter fall under multiple rule parts?
Typically, no. There may be some cellular devices that may have different rule parts, but a single radio frequency device is typically governed by a single rule part. You could have, now that said, there are different sections under different rules. For example, under Part 15C, you could have a device that may fall under different sections of that rule part, but it's the same rule part, and may depend on your use of that device and the frequency range. So it's worth examining if you have a device that may not work in one particular section of the rules. There may be some other ways to do it. And we've seen those applications before. So typically, when the certification is said and done, you get a grant for one rule part for that transmitter.
Okay. Well, it looks like we have all the questions answered. Thanks a lot, Mike. It's been interesting.
Thank you, Christy.
Sure. If it's all right with you, before we go, I'm going to quickly go over some upcoming training from Washington Labs Academy. So hopefully everyone can now see my slide here. The link displayed on the screen connects you to our Academy webpage, and you'll find information on all of our webinars, resident courses, available on a variety of engineering, design, and testing topics. Some of those are listed here. Product safety, we have session 6 on June 21st. We're going to cover fire and flammability. MIL 461G, according to the instructor, Mr. Steve Ferguson, CS 114 has lots of changes, so if this is something of interest to you, you might want to attend. That's coming up June 22nd. MIL Standard 810G, environmental, session 6, that's going to be on June 23rd, vibration and shock. The next in our IEC FCC EN series, session 5, that's going on July the 12th, and that's going to cover power plant issues. We also have a hands-on course coming up in September on MIL 461G testing, so if anybody's interested in that, or if you want to check out any of our previous webinars, please note all of them are available for purchase from our website. We also provide customized training at your place or ours, and webinars are available in multi-part series, so you could mix and match them, meaning you could take one session or a few from any combination of available webinars from any multi-part series, or you can sign up for a complete offering of the Academy training courses happening throughout the calendar year. So please be sure to give WLL.com Academy training page a look and check out our course topics and dates. We'd also like to hear from you with suggestions on any future topics that we might be able to present. And with that, that's going to conclude today's webinar. So on behalf of myself and Washington Labs, I'd like to thank everyone for their attendance. At this point, I will go ahead and end the event. Enjoy the rest of your afternoon, everyone. Bye-bye.